Welcome and thank you for taking the time to view this brief presentation on Superior 950 series brass valves. The valve shown here is the Model 950, the original and best-selling model in the series. It was introduced in the early 1970s and is available in 3/4 through 3-inch sizes. One of the reasons for its popularity is parts interchangeability. All of the parts in a new 950 are interchangeable with the parts of a 950 that has been in the ground for 40 years. Public agencies in particular appreciate this as it makes their job easier. I am going to talk about 3 other models in the series, but first I'm going to talk about principles of operation, how a valve functions, what makes it open, and what makes it close. These principles not only apply to the 950 series valve, but most other electric valves as well. Okay, 3 common components found on just about all electric valves are the ones shown here: the manual bleed valve, solenoid, and flow control stem. Okay, first the manual bleed valve. The diagram on the left shows the valve in the closed position. As you can see, that water was able to enter the diaphragm chamber through an opening in the diaphragm shaft. In order for the valve to open, pressure needs to be relieved from the diaphragm chamber. One way of relieving the pressure is by opening the manual bleed valve. Manual bleed valves fall into 2 categories: internal manual bleed valve and external manual bleed valve. The valve depicted in the diagram is the Model 950, which has an external bleed valve, or manual bleed screw as it is commonly called. To open the manual bleed screw, you unscrew it a couple of turns counterclockwise until water exits to atmosphere through a small hole in the wall of the bleed screw. With the pressure relieved in the diaphragm chamber, the valve opens. The entire time the valve is open, a stream of water will continue to exit the bleed screw. When the bleed screw is closed, water entering the diaphragm chamber has no escape route, so the chamber fills and the valve closes. Okay. Like the manual bleed valve, the function of the solenoid is to relieve pressure from the diaphragm chamber so that the valve can open. Inside the solenoid stem, there is a cylinder in which a spring-loaded plunger can move up and down. When the solenoid is not energized, the plunger is in the down position and seals the exhaust port located at the bottom of the solenoid cavity, as you can see in the diagram on the left. When the solenoid is energized with 24 volts, the plunger lifts and unseals the exhaust port, allowing water in the diaphragm chamber to escape to the downstream side of the valve. With pressure relieved, the valve opens, and it will remain open the entire time the solenoid is energized. In addition to water flowing through the valve, a small amount of water continues to enter the diaphragm chamber but quickly exits through the exhaust port. When the solenoid is de-energized, the plunger drops down and seals the exhaust port. As water continues to enter the diaphragm chamber, it has no place to escape, so the chamber fills and the valve closes. Okay, this slide shows an animation of a valve opening and closing. In order for the diaphragm chamber to fill and close, there must be pressure loss through the valve. So let's open the valve. Okay, as you can see, the plunger lifted and the valve opened. And when the valve was de-energized, the plunger dropped, but water continued to enter the upper diaphragm chamber, but with no place to escape, it filled the cavity and the valve closed. But in order for it to close, there needs to be a pressure loss. As water flows through the valve, it undergoes turbulence, which results in pressure loss. The higher the flow rate, the higher the pressure loss. A 1-inch Model 950 with a flow rate of 18 gallons per minute has a pressure loss of 2 pounds per square inch. So if the pressure entering the valve were 60 psi, the pressure exiting the valve would be 58 psi. In this example, as the valve is closing, the pressure above the diaphragm is 60 psi, while the pressure below the diaphragm is 58 psi. This pressure differential is why the valve closes. There's a spring above the diaphragm, but the spring is not relied upon to close the valve. It just helps get it started. Okay, the flow control stem is used to adjust the amount of flow through the valve. Quite often there is too much flow through a valve, like when you see misting from the sprinkler heads. Even a slight breeze will carry the mist away, resulting in water waste. To set the optimum flow rate, turn the flow control handle to the full open position by rotating it counterclockwise as far as it will go. Next, turn on the valve electrically and while observing the spray from the sprinkler heads, rotate the flow control stem clockwise a half turn at a time. When a slight reduction in the radius of spray is observed, rotate the cross handle a half turn counterclockwise. This is the optimum setting, also known as the balance point. Okay, unlike the diaphragm assembly of most electric irrigation valves, the Model 950 has a two-piece assembly with a space between the diaphragm and the seat disc. An advantage of this design is that the diaphragm is not in the flow path and is therefore less likely to be damaged by debris. Underneath the exterior rubber coating of the diaphragm is a nylon cord material with a burst strength of 600 pounds per square inch, so the diaphragm can last a very long time. All of the rubber parts in the valve are made from EPDM rubber compounds. In years past, the rubber parts of most irrigation valves were made from Buckner rubber compounds, but due to the vulnerability of Buckner rubber to chloramines found in reclaimed water, the switch was made by most manufacturers to EPDM compounds as the use of reclaimed water increased. Okay, the picture on the right shows the inlet orifice at the bottom of the diaphragm shaft through which water passes on the way to the diaphragm chamber. The metering rod that protrudes through the orifice is attached to the flow control stem. The purpose of the metering rod is to prevent dirty water from entering the diaphragm chamber. Dirty water can cause solenoids to jam, resulting in the valve not opening. There is only 0.003 of an inch of clearance between the metering rod and the wall of the inlet orifice. So even if the metering rod were all the way to one side, no particle larger than 0.006 of an inch in diameter could enter the diaphragm chamber. The solenoid exhaust port is a 1/16 of an inch in diameter, so any particle that is only 0.006 of an inch in diameter would easily pass through the solenoid exhaust port. Okay, the Model 950 DW provides even more dirty water protection than the Model 950. The only difference between the two models is the 80 mesh stainless steel screen that is screwed onto the bottom of the diaphragm shaft. This would be the model to use for well water applications or pond water applications. The screen does an excellent job of preventing biological material such as algae from entering the diaphragm chamber. The screen is self-cleaning because it is in the path of the water flowing through the valve. Okay, this is the 950 DWIB. It has all of the features of the 950 DW with the addition of a manual internal bleed valve. When the handle of the ball valve is turned up 90 degrees, the valve opens as water exits the diaphragm chamber and flows through the tubing to the downstream side of the valve. For reclaimed water applications, the valve is available with a purple cross handle by adding RW to the end of the model number when ordering. By the way, all other 950 series valves are available with purple cross handles by adding RW to the model number as well. Okay, this is the Model 950 PRS. It has all of the features of the 950 DWIB with the addition of a pressure regulating module that allows the end user to adjust the downstream pressure within a range of 10 to 125 psi. Once set, downstream pressure remains constant regardless of variations in upstream pressure. One requirement is that the regulated downstream pressure must be at least 15 psi less than the upstream pressure. So if the pressure entering the valve were 120 psi, then the regulating range would be 10 to 105 psi instead of 10 to 125 psi. To set the downstream pressure, the end user pulls up on the knob at the top of the module to unlock it and then rotates the knob counterclockwise to decrease downstream pressure or clockwise to increase downstream pressure. Once the desired pressure is reached, the end user pushes down on the knob to lock it in place. Okay, this concludes the presentation on 950 series. I'll be happy to answer any questions at this time.
Yes, I had a question. Some other manufacturers have pressure regulating modules that can be installed in the field on the top of their standard valves. Why doesn't Buckner Superior make a regulating module that can be added in the field?
All right, we've considered that, but the issue is this. In order for the downstream pressure to remain constant, the regulator must react to changes in upstream pressure. The pressure regulating module on the 950 PRS, which is mounted on the body of the valve, reacts faster than top-mounted regulating modules. This has to do with the proximity of the module to the flow of water and to the size of the inlet leading to the regulator. So many designers specify the 950 PRS because of the quick reaction time to pressure surges, so we have decided to leave well enough alone. Any other questions? Yes.
In the presentation, you stated that the only difference between the 950 and the 950 DW is the filter that is added to the bottom of the diaphragm shaft. How can you tell if the valve that is installed in the field is a 950 DW instead of a 950?
Okay, a green washer is added at the top of the solenoid underneath the retainer nut. So if you look down in the valve box and you see a green washer under the solenoid retainer nut, you know it's a model 950 DW. Okay, any other questions? Yes, sir.
What is the minimum and maximum pressure at which a 950 can operate?
Okay, the minimum pressure is 20 psi and the maximum operating pressure is 200 psi. Okay, any other questions? Yes.
Is there a latching solenoid that can be installed in a 950?
Yes, the part number is 16305. You can also order a 950 with a latching solenoid. The model changes to 960, so if you want to order a 1-inch size, for example, you would order a 960-100 instead of a 950-100. Anybody else? Yes, sir.
Are troubleshooting guides available for all the 950 series valves?
Yes. On our website, there are troubleshooting guides for all of our valves. The guides include disassembly instructions with photos and a parts list as well. Okay, anybody else? Yes, sir.
What about on-site troubleshooting assistance? Does Buckner Superior provide that?
Absolutely. When the request is made, we give it our top priority. Okay, any other questions? Okay, well, that's a wrap.